Welcome back to the Java Coffee to Code channel. This is the 8th video in the series. So I'm sure you had very good lunch, breakfast or dinner. At what time you are seeing this video, I don't know, because we'll be really diving deep into the Java concepts, core Java concepts, and there will be a lot of theory followed by some examples. All right. So first thing that I want to say, if you have watched my previous videos in terms of program, so we all know now that a program is nothing but it is a set of instructions. So a program is a set of instructions. So you can consider the machine, the computer, like a baby which cannot see, hear, only can think the way you want them to think. So you really have to be detailed in terms of giving instructions for the task that you want to achieve. So that is what is programming is, achieving a given task by giving a set of instructions to follow. So first thing what we did was, when we set up the Java on our system, we installed something which was called as a JDK, if you remember JDK. Now what the hell is a JDK? JDK stands for Java Development Kit. So this development kit has all the tools that you require to actually go ahead and create, build and run Java apps. All right. So it contains all tools for building and running Java programs. Another concept that we need to know, if you see here, is something which is called as LTS. Now ever since Oracle has taken over the Java programming software, it was first given by Sun Microsystems. So they have always been coming up with some or the other version of the Java in every 6 months or something. So the latest one under development is Java 21. We'll have a small discussion about it also. So far what I know about Java 21 is very interesting, but to appreciate its features you need to know at least what basic Java is. So LTS here is something which is called as a long-term support. So not every version of Java is a long-term support. So for example, you can see Java 8 updates will end by December 2030, and Java 11 is actually an LTS because it will go till September 2026. Okay, it is not an LTS, but most of the current features of Java start from JDK 11. That's why I told you to keep Java 11 minimum on your system. All right. But if you look here, I say that it contains all tools for building and running Java programs. Did you ever, I'm sure you at some point of time you ran some or the other Java app without knowing, of course. So how did you run it when you did not install the JDK? So answer to that is called as JRE, which is Java Runtime Environment. What it means is, it sets up the system on which the JRE is installed for running, creating a conducive atmosphere for running a Java program. For example, let's say you want to sit down and learn this course. All right. So what all things you would need? We already discussed that in Java 2. You need in the second video, Java Coffee to Code 2. You need a system, you need internet connection and patience and hard work and all that. But apart from that, what would you need? You would need a learning environment, like a quiet place, a table and a chair, some pen, paper to write down things. So that is called as an environment. Can you actually go ahead and learn where there is a band procession going, somebody's marriage procession is going, that barat that goes dum dum. So can you sit down there and learn? No, because there is no environment there. So JRE basically creates the conducive environment for the system to efficiently run a Java program. Now you don't know, you have never installed JRE because it automatically is done by any Java program that needs to be run on your system. A little over your head right now, don't worry. So basically the JDK that you will download includes the JRE automatically in it. Logically, I told you it contains all tools for building and running a Java program. So you have the JDK, you have the JRE. Now another thing that you need to understand is language. Now if you look at the first program here, the first one that we did, the hello world thing. So do you see regular English here or something else? I mean, it does look like regular English, right? And even makes sense, something like system.out.println. So you understand it is going to something called as a print thing, and then there's the quotes, and you tell the system to boss, please go ahead and print this on the console. But to be very honest, do you really think this system that I'm sitting on actually understands that English? No, it does not. So there are two concepts involved. One is a high level language in which we write programs understandable to us. So mostly it is English or any native language, German, Chinese, Korean. So in the language that we write, of course it's not exactly proper English, you don't talk to people like that, but at least it's understandable to us for creating. So that is called as a high level language. Then there is a low level language, which is also what we call as the machine language. It basically means all zeros and ones, 0 1 0 1 0, the way machine learns. I mean, machine only runs in understands the language of zeros and ones, which is also called as the byte code. Okay, now what is a byte? A byte is just 0 or 1. Okay, so the code that is written in byte is called as a byte code. So this is what the machine understands. So basically what you do is you convert the high level language into low level language. So basically any programming language, what it does exactly what I'm going to show you. So it converts high level language into low level language for machine to understand, and the low level language again gets converted to high level language so that we can see the output, and on the screen you actually see something called as hello world, I'm starting Java. Am I making sense? So basically any programming language, it does in it just converts the instructions that we give. The program is a set of instructions into low level language and then returns back into the high level language. Okay, so programming languages can be of two types. They can either be a compiler, or it can have an interpreter. Now what these two means? Compiler simply means that entire program is converted into machine language and then executed. Okay, don't worry, we're going to discuss this again. Interpreter means the program is executed line by line. So what it means is, what it basically, this particular concept means is that whenever you write a program in Java, so Java is a compiled language, and Python is interpreted language. So what it means is, when you write a program in Java, the entire program is first converted into the machine language. So if you remember the hello world or the assignment one that we did, it converted it into a file called as hello world.class, and assignment one into assignment1.class. So the next item that you type, that is Java space hello world or Java space assignment1, you're basically running this item here, the bytecode language that we created from the Java. So it would not let you run this program till it is able to compile it successfully into a bytecode. So consider it more like your mother as in when you were young and you were about to go to school, she would give you a thorough check from top to bottom. Your uniform is okay, you have the lunch box, you have the water bottle, you have the necessary books, any assignments that you are supposed to do, you are carrying it, your hair is combed, your shoes are polished, your nails are done. So then only you were allowed to step out of the house. So consider the compiler something like that, wherein you are supposed to make sure the entire thing is correct, then only it is getting converted into the compiler, into the machine bytecode. But interpreter is more like me, when I am taking care of my son, we would be rushing out of the door, then we realize, okay, books forgotten, so we come back, we take the books, then we go again, lunch, okay, I'm not that bad, but just giving an example. Interpreter, what happens is it executes line by line, 1 2 3. So let's say there's an error in line 5, so it would execute till 4 and then stop at 5 that you have an error at line 5. So both have its own pros and cons. There is no competition here which is better or which is bad, but Java is a compiled language. Now where is the Java compiler located, or actually how do you compile? So it is located in the bin folder. Now you must be surprised, or I don't know if you would already guessed by so far how it works. So if you remember, if I did the command which we wrote here, okay, this is the path that I have from the bin folder. So I'll just open this. Also on the Windows, if you remember, I told you to go ahead and make sure you remember where the bin folder is. So in the bin folder is the Java C command. You see, remember this Java C we do. So C stands for the compiler. So when you write Java C space the file name, it is an instruction for Java to convert that particular code, the high level language, into machine language or bytecodes. Okay, and you remember the Java version that we write, Java space minus version, is also located here, and the running of the Java space the file name, this is the command, it knows how to do it. The same thing is in the Windows. If you have a look in the bin folder, you will see that is where all your items are located, and that is where the the system goes and finds the command. All right, so Java C space the file name .java actually converts machine language into, not machine language, high level language or program into machine language. That is all zeros and ones. Okay, so Java has a very nice name, something that we called as platform independent, or it is also called as write once, run everywhere. Why is it called as that? I'll just come to that. What happened was, when Java was introduced way back in 90s, when the world was all about C and C++. Okay, you might not be knowing this, just informing you. But C had an issue of, depending on the system configuration for proper running of the program. So for example, if I wrote something on my system, on your system it may not appear the same way, for simple reason being that it was depending on the configuration of the system it was being run on. So Java overcame this problem, and it became something called as platform independent and write once run everywhere, by using something which was called as a JVM, or Java Virtual Machine. What this simply means is, a virtual machine is created inside the target compute machine, inside which the Java program runs. Now what I mean by this is, what Java does, so this is where the JRE comes into the picture, the Java runtime environment. So I'll just mention that also. So what happens with that is, in the target machine, a virtual whole machine is created inside the target machine, and inside which the Java runs. So for example, no matter what your system is, your environment remains the same. So you find the platform absolutely same wherever you run, and you get a wonderful, you get the same output every time. So what it really means is that if I go to this particular class and assignment 1, you can take these, bytecode language to any machine, a Linux or a Mac or Windows, no matter it is created on Mac or Windows, doesn't matter. This would run absolutely same on every machine. You don't have to rewrite and rerun every time. Am I making sense? This particular .class files, you can copy it on any machine, and it runs absolutely same, not even a single difference. So that is why it was called as platform independent. So what are the platforms? The platforms are Mac, Linux, Windows are the main platforms. So irrespective of where it is written, you can write once and just run everywhere. Now I have a simple question for you, if you are willing to answer. The question is, if Java is platform independent, that means this particular class file can run on any machine. Once it is created, I can just copy paste it anywhere and it runs perfectly fine. Why do we have different JDK downloads here? I mean, if it is platform independent, I should have just one JDK download, right? Irrespective of the fact you install it on Linux, Mac OS or Windows. Are you understanding my question? I'll just rephrase myself. If Java is platform independent, you don't have to worry about just write it once and run everywhere. Then why do we have different JDK installations for different platforms? We should have just one installation, right? Common installation. Okay, I really hate it when you can't answer me back. So answer to that question is very simple. The answer is that Java is platform independent. Nobody is doubting it. I mean, you have to write it once and run everywhere. So basically this bytecode is independent, but the compiler, the main compiler which actually converts the program into machine language, is not machine independent. So you have different compilers for Linux, Mac OS and Windows which give out the same result, I'm not denying, but these compilers are dependent on the platform. So I have a small thing to show you. So this is what basically happens. You have written the hello world.java. It goes to the Java C which you did. You compiled it into Java C, the file name. Then it gets converted into a bytecode. So this bytecode is platform independent, but this compiler is not. Do I make sense? And then it goes into the Java virtual machine. Now this may be a little over the top for you right now, but I'll just paste this into the notes. Maybe later we can go through it one by one, or the more you do the programming in Java, it would make much more sense. So you have the entire JVM here. So this entire JVM, actually runs this particular bytecode. This bytecode is run by JVM properly inside this, and you get the same output irrespective of the operating system that you have. Make sense? So what I'll do is I'll just copy, give this in the notes for you so that you can have a look. I should really start charging you for the notes. What do you think? Okay. So this is how it works, the flow of your Java file. All right. So okay. So the JVM is Java virtual machine, and the Java again is a platform independent language, or write once run everywhere program. You know why? It's the bytecode, that dot class thing that you create of the program is which is your basically platform independent. Now the next thing that I need to tell you is something called as syntax. Now when you hear the word syntax, when I heard for the first time what syntax is, that tank came into the mind, this one. So, but of course that is not in the programming language. You don't need water tanks for that. The spelling here is something that is called as a syntax. What does this syntax means? It's the way to write anything. So what it means is, I'll be using this word syntax a lot. Syntax means the way to write. So for example, if I tell you the syntax for writing a method is this, so you would know that okay, that is the way to write anything. All right. Now let's see quickly what we created in terms of Java first program. Now you see something here called as a class. Okay. So I'll just write it here. Any program in Java is inside a class. So this is like the thumb rule. Anything that you create will be inside a class. Okay. And the class of course is in smalls. Class is in smalls, as in all small letters. And the next thing that you saw here is something like this, which you saw in both the code. So even if you see the solution link, you would find the same public static void main here. Let me also zoom this for you. So this also has a class, this also has a public static void main. So what is this public static void main? We'll go, as we go along, we'll talk more and more about it. So I'll just reduce it here. So this is something which is called as a main method. Now what is a main method? Please understand, every program in Java must contain a main method, because when your program runs, this is what the JVM looks for. Where is the main method? So even if you have a huge project of, let's say, interspace galactic mission created in Java, that would also have a main method. This is where execution takes place. What is a method? We'll discuss much more in detail. You'll be creating your own methods and whatnot. but this remains like the God's truth. You cannot escape a main method. All right, for now just remember this is how it would look like. And apart from that, there are some things here which I need to explain it to you, so which I am going to explain one by one. Now these, I'll just increase the font and you would know what I mean by them when I say it again. So these are something which is called as the curly braces. Now you can see they are very curly in nature. Okay, so these are called as the curly braces. They exist in the Java program. You can see for the class, for the main method, they both have. Okay, then we have these brackets, the regular brackets. So I won't be calling them regular brackets, I would just call them regular. I remembered a joke on this. There's a very nice saying, what do you call Brazilian nuts in Brazil? So the answer is just nuts, because you're already in Brazil. So similarly, I would not call them regular brackets, I would just call them brackets. Then you have something which is called as, so I'll just copy paste this so I don't have to keep on changing the font. Now these are something which is called as the square brackets. Square brackets. So you saw the regular brackets here, here, and then here are the square brackets. Can you see that without space? Okay, these are parts and parcel of your Java coding. Then this is something which is called as a semicolon. All right, this is, as I told you, next to the L on your keyboard. Then this is called as the full stop, which we have in English, or the dot. These are called as the dot operator. We will talk about it more, and you actually saw the dot operator here. It's not a full stop. These are the dot operators. And then you have the regular then you have the curly brace. Yeah, others, there are many other things like colon is there. We'll talk about it as and when we move forward. So for now you can remember that these are the thing, and I also mention it here. Every code line inside curly braces ends with a semicolon. So you can see everywhere, whatever is inside the curly braces, every line ends with a semicolon. So this is like, again, God's truth. These are the basic rules of Java. All right, so I'll just recap quickly. Any program in Java is inside a class. So class is a must. So your naming is there, and your class is there, and the name is after the class. Then every program must contain a main method. And finally you have these items, that is the curly braces, the regular brackets, the square brackets, semicolon, the dot operator, and more as and when. Then you have the question mark thing, and so on and so forth, which we will discuss as and when we move forward. All right, finally the biggest question, I think what must be in your mind in case you are paying attention is, do we actually write Java programs like this? I mean, we can. I remember when Java 2.0 came way back in 2004, Java 2.0, that is where I started with Java. We were always told in the tutorials to, write down in Notepad and then get to some software. But I find that very, it's not actually a good practice. Why? Because the world is changing. I mean, So I am in Chat GPT, which I am sure you must have heard a lot. So if you just say write a program, in Java that prints hello world. So in seconds it gives you what you required. Can you see that? In seconds it gives you something which is called as the Chat GPT. So this is where AI is. So didn't want to demoralize you that machine can also write code, but just wanted to tell you that it doesn't matter if you don't write it in a notepad. So what do we use in reality? That is the term called as IDE. IDE stands for Integrated Development Environment. So for example, all the software languages have their own IDE, and if you try to see what all the IDEs for Java, so these are basically the software that programs that help you write code in a better way. You will see a lot working with IDE, like you saw VS Code that keeps on popping on my system. This is also an IDE, Integrated Development Environment. This is for web development, Java, anything and everything. So how many types of Java IDEs are there? There are plenty. I mean, if you just look at, I've just googled a few. So I have used Eclipse, NetBeans, IntelliJ, BlueJ, Xcode, because I'm using MacBook. This is MacBook specific. But my there is no discussion. As I told you in the very first video, there is no discussion which is the best. We would be following Eclipse for this particular tutorial or the course, for simple reason being that Eclipse IDE for Java, for simple reason being that Eclipse, if you see, is open source. Now what is mean by open source? It is developed by developers across the world in collaboration. Nobody is getting paid or charging anything, and it's free absolutely. Okay, and most of the MNCs that I know, multinational corporations that I know in India at least, they use Eclipse for development. It's a very well versed thing. I even liked IntelliJ idea a lot. But there's only one problem. IntelliJ is not free. There are two versions of it. One is a free version, which is a community version, which is good enough for you, and there is a paid version which has got many advanced features. But again, people like me who don't want to spend on learning something, so we would be going ahead with Eclipse. So that brings an end to today's session. In the next two videos, again I'll tell you how to install the Eclipse IDE. The link is already given here for MacBook and Windows in two videos, and running your first hello world program. So once you have downloaded Eclipse, ran the whole thing, the first hello world program, then we can continue further on our journey. All right, so see you in the next class.